Hey guys, we're on lesson 7.4, task 1. So we're going to graph cube root functions. Alright, it says to graph the parent cube root function, recall that the parent cube root function g of x equals the cube root of x is the inverse function of the parent cubic function f of x equals x cubed. Both the domain and the range of the parent cube root function are the set of all real numbers, just like the parent cubic function. The table represents some values of the parent cube root function. G of x equals the cube root of x. Alright, so since the cube root of x is the inverse of x cubed, you see that they have picked values that are perfect cubes. So those are easier to evaluate because you're going to get exact numbers. Alright, so it says you can use the ordered pairs from the table to sketch a graph of g. Alright, so you've got x and g of x. G of x, remember, is just another way to write y. Alright, so you can use the ordered pairs from the table to sketch the graph. So negative 27, negative 3. So you can see on the y-axis or the g of x axis, it goes 1, 2, 3, 4. The scale is of 1. But on the x-axis, it's 0, negative 5, negative 10, negative 15, negative 20. So the scale goes by 5s. All right, so summarize the characteristics of the graph of the parent cube root function. All right, so since it's a function and it goes in both directions continuously with arrows, we can say that the domain and range are the set of all real numbers. What are the intercepts of the parent cube root function? Okay, so you can look at the graph, and the x-intercept is at 0, and the y-intercept is also at 0. And a lot of your parent functions, you'll notice that that's what's going to happen. It's going to intersect at 0, 0. Is the function increasing or decreasing? Where is it positive and where is it negative? So the function is always, so if you look at the graph, you can see that from left to right, the function is always going up, so it's always increasing. And it is negative up until 0. So you can see here it's negative until 0, and then it becomes positive after that. So it is negative for all x is less than 0, and it's positive for all x is greater than 0. All right, does the parent cube root function have any maximum or minimum values? The answer is no. Since it continues in both directions with arrows, it has no maximum or minimum. And you can tell that using the in behavior. So let's see what the sample says. There's no max or min. The values of the function increases without bound as x increases without bound, and the value of the function decreases without bound as x decreases without bound. So again, that's just showing your in behavior. Since it continues in both directions with arrows, that means it's increasing without bound. All right, so as x approaches negative infinity, the cube root function approaches negative infinity, and x approaches positive infinity, the cube root approaches positive infinity. So you can see that looking at the graph too, as x goes negative, so as x approaches negative infinity, the y value approaches negative infinity too, because it's going down without bound. And then here as x goes positive, your y's are also going positive. So that's going in the positive direction without bound. All right, it says describe the average rate of change over equal intervals as x increases from negative infinity to 0. Describe the average rate of change over equal intervals as x increases over 0 to positive infinity. So as you look, so the average rate of change is going to increase as it gets closer to 0. And then after 0, from 0 to positive infinity, it gets less. So it's decreasing after that point. So it's basically just looking at the graph. So it says for negative values of x, the average rate of change increases as x approaches 0. And for positive values of x, the average rate of change decreases as x increases without bound. All right, that's all for task 1. We will move on to task 2. All right, we're still in lesson 7.4. This is task 2. So to graph a cube root function. Transformations of parent cube root function. The transformations discussed in the previous lesson have the same effect on the parent cube root function. The specific transformations can be determined by identifying the parameters a, b, h, and k when a cube root function is written in either of these forms. All right, so you should notice that this looks very similar to what we looked at before. So it's going to be a cube root of x minus h plus k. H and k is your vertex. Or g of x equals cube root of 1 over b, x minus h plus k. Okay, again, where h and k is your vertex. So the parent square root function, that should say cube root function, the parent cube root function, f of x equals cube root of x, is shown in each of the following figures. All right, so we got the cube root. The parent function is in black here, f of x. And then you can see that just like before, if it's in parentheses or under the radical sign, it's going to go opposite the way you expect it to. So plus h will shift you to the left, and minus h will shift you to the right. All right, outside of the radical is going to shift you up or down, so your k is your vertical movement. So if it's plus k, it's going to shift you that many units up, and if it's minus k, it's going to shift you down. All right, if the negative is underneath the radical, the cube root of negative x, it's a reflection across the y. And if the negative's outside the cube root, it's a reflection across the x. All right, your vertical stretch and compressions. Vertical comes from your a. If your a is greater than 1, you've got a vertical stretch by a factor of a. You can see that in g of x here. Okay, and then if it's 1 over a, if it's between 0 and 1, basically it's a fraction, then it's a vertical compression by a factor of 1 over a. And then your horizontal stretch and compressions comes from your b value. The b will be located under the radical. So the cube root of b x is a horizontal compression by a factor of 1 over b. And then if you've got cube root of 1 over bx, that's a horizontal stretch by a factor of b. So again, this is similar to what we looked at in the last section, but now we're dealing with cube roots. All right, so it says for each cube root function, identify the values of a, b, h, and k. All right, so we look at this. If there's no a, that's assumed to be a 1. H and k, there's no h, there's nothing under the radical, so that would be 0. And k is negative 4. All right, looking at b, cube root of x minus 1. Again, there's no a, so we're going to put a 1 there. When there's not a number, you can't put 0 because 0 times this makes it go away. But 1 times this, 1 times anything is just that same thing. So a has to be a 1. Now h is going to be x minus h, so that's going to be a 1. And then k is still 0. And then for this one, a is 6. There is a number there this time, so a is 6. And there's no h and no k. For d part, there's no a, but there is a b. b is 1 over b, so this is going to be 2. And there's no h or k, so those are going to be 0. And then for this one, a is negative 1/5. And then there's no b, and there's no h or k, so 0 here and here. For this one, there's not an a. We'd assume it to be a 1. I don't know why they put NA there, but we are going to put negative 1 for our b, and there's no h or k. All right, so what we're doing is just identifying the a, b, h, and k for each one of these, and let's see what happens. All right, so it says the transformations with square root functions have the same effect on the parent cube root function. All right, so the transformation of cube root functions have the same effect as parent cube root functions, I guess. So square roots and cube roots basically work the same. All right, so the next section here is matching. So it says describe the effect of each parameter has on the graph of the function as compared to the parent function, the parent cube root function. Use a graphing tool to check your responses. All right, let's see if I can shrink this down a bit. Oh, I thought it would be easier to match if you could see all of them at once, but for some reason it's not letting me do that. All right, so let's just look at them a little bit at a time. This is going to shift us 4 units down. So let's see which one says shift us 4 units down. All right. So that's going to go with this one here. And then this one's going to shift us to the right 1 unit. All right, so this one's going to shift us to the right 1 unit. This one's going to be a vertical stretch by a factor of 6. All right, so the vertical compression, the graph has a factor of 1/5 and reflects across the x-axis. Because this is negative, it reflects across the x-axis. All right, now we have a reflection of the graph across the y-axis. And this is a horizontal stretch by a factor of 2. Remember, that's 1/b. All right, so that is all for task 2. If you have any questions, please let me know.